This is the Electron 2 session, and what we're doing is developing the idea of the electron, how it works, how it exists around the nucleus. And remember when we talked about hydrogen, hydrogen's the simplest of all atoms. It has a proton, which is the nucleus. Remember we said that nucleus is about 10,000ths the size of the atom, and there is one electron. That's it. No neutrons. This is the only atom with no neutrons. Niels Bohr spent a lot of time explaining how this electron worked, because Niels Bohr knew that around this proton, if you had an electron traveling around it in a circular orbit, as it traveled, it would give off energy. It would give off energy, it would slow down, and eventually it would collapse into the nucleus. And that doesn't happen. So he came up with a new model. A revolutionary model of a way of looking at an atom, in the simple atom, hydrogen. And he said this, number one. He said that there are fixed orbits that electrons, when they're at that orbit, they would give off no energy, no radiation. Now think about this. See, normally is something going around the nucleus, you say, well, it can only be at certain fixed distances. When it's at those distances, it doesn't radiate, so it can stay there forever. And the third thing is, we'll talk about, is these are energy levels, fixed distances, there's more than one. So you can add energy and you can have electrons move from level to level. They can go to a higher level, and when they drop back to lower levels, they give off radiation, light. I'm just using some shorthand words here. This light is a word that Einstein coined. It's called a photon, a particle of light. Now, let's look at these levels. And what I'll do is I'll use our straight line tool here and see if we can get this across. Here we are. Okay. Now, a little quick information here. If you take hydrogen, the hydrogen atom, and I'll put a dot representing an electron, we know this, that if you use a very incredibly small amount of energy called electron volts, 10 to the 18 electron volts is 1 joule. So a very small amount of energy, you can rip off that electron and it becomes a hydrogen ion, and here sets that electron. So the reverse process of gaining that electron sets a point of stability where the electron exists most of the time at a minus 13.6 electron volts. This is called level 1. Level 1, closest to the nucleus. The nucleus is right here. So now, what Bohr said is the electron stays here, is happy. It doesn't radiate. That's a certain distance from the nucleus. And this distance from the nucleus is a basic radius of the nucleus. And I think for hydrogen is about 37 picometers distance. So here's what happens. When we heat the atom up, it will jump to a second level. It doesn't go anywhere in between. So these levels, going to the second level, these levels are called quantized levels. Don't let that scare you. Quantized means if you're going on a ladder, you can put your foot on the first rung or the second rung, but nowhere in between. The electrons will not settle for any place in between there. So the second level is defined by an equation. The energy levels is defined by the energy 13.6 divided by n squared, where n is a level. N is equal from 1 on up to 7 is for about the furthest you could go where it makes sense, not even 7. So when it goes up, level 1 is 1 squared, level 2 becomes 4 into 13.6. The second energy level is now minus 3.4 electron volts. So electron can be, you heat it, it can jump to this level, and when it falls back, it gives off light, and that's called a photon. You get this energy going in. It could be electrical energy when you heat up an atom, and when the electrons jump back to this lower level, they give off a light. Hear that word, quantum of light, a photon. The third level would be 3 squared is 9 into 13.6, and that is 1.54. Now when it gets out to infinity, the energy here is 0. This is the level of energy to remove that electron completely, to make it into a pure proton, a hydrogen ion. Okay? Now Bohr did this work at Cambridge University, but he also worked with Rutherford, who had moved to the University of Manchester in England. And Niels Bohr also worked in Los Alamos in the Manhattan Project in the United States. But look what happens when it gets to 4. And now they get very, very close. These rungs are very close together. And it minus 0.85. And it keeps going down. 8.5, 5.4, 3.8. And these are not in proportion now. And even about 0.22. So this is sort of a strange ladder. It's very close together. So here's what he did. Niels Bohr's work was just an intermediate work to the modern quantum model of the atom. But he taught us that we need to look at the atom as a major concept. It's called the principal quantum number. And this number is literally from 1 to basically 7. And this is the levels the electrons will be in a distance from the nucleus. Remember the nucleus is very bad. And the levels keep getting closer and closer together. But these fixed levels are called the periods of the periodic chart, but they're called the principal quantum numbers, and they define the basic distance. And we'll find out that next we're going to go from electron as a particle to the electron as a cloud of charge in the next tape. And that's because of something called the Heisenberg uncertainty principle. It's going to show you that we can't call the electron a particle anymore. It has a probability model, not what's called a deterministic model. Don't worry about that. Okay, so here's what Bohr did. Bohr introduced the idea that there are fixed levels of electrons from a nucleus. They are not equal interval levels, but they will help us understand the whole building process of atoms as we go into the next tape. And we're going to stop right there.